Hello, good morning, students. Homework 3 have been uploaded, and I just want to give uh, some instructions regarding the homework number 3. So there are three different tasks in homework number 3, as you can see on the right side. So for each task, I'm gonna solve one problem one by one, and please try to follow the same pattern for all the subtasks. Okay, so first of all, try to clear your environment by pressing the console by pressing Control L, clear your environment by clicking here, and by clicking here the plot as well. So let me add everything very quickly. So it is my homework 3, and I will start with the, let's say you will start with the your name, your ID, and maybe date, and whatever information you want to add, you can add. At least there should be name and ID. So in task 1, they say that plot the following equations in R using plot function. In R, we can plot a graphical representation of an equation by several ways. But in this particular exercise, we're going to use the plot function. All right, so select at least 20 values within the interval. For example, if you choose X interval is like 0 to 1, then ensure that there are 20 values. Let's just try to explore this. So let's take the example, task 1 and part 1. Let's say our part 1. All right. So in here, we have equation. Equation is given by, let's say I write y is equals to 1 plus log. Here they say that log, so let's just go with the log x. And then we can say that minus x by 2. All right. So 1 plus log x minus x by 2 is y. And let's just have the values of x. So let's say x is, let's just try to get a sequence from 0 to 1 and length out equals to 20. All right. So let's just run x. We have this x and corresponding value of y. So if you see x in here, if you see x in here, start from 0 until 1. And once you see y, there are some values that are infinity. So I just want to remove that. So let me just take an interval between 0.001. So it will remove my infinity value. So now I have y is equal to y starting from minus 5.9 until like this one. All right. So now I can see that that all of my values of y, they are real numbers. So I can plot it. So quickly we will go plot function in R and then just write x and y. We need these two things basically. If you plot it, you will see a plot on the right side. But this plot is not complete. I want to have a plot that shows me a line. So I would say I will add L. This is L, not 1. So I will run it again. It gives me a line. Also, I want to add line width should be equals to 1. I want to increase the line width. Let's just add it. I think I should line width maybe 2. It will work. Or maybe 1.5 gonna be okay. It just depends on you whatever you want to add. Line width, right? So I think 2 gonna be okay for me. Then I just want to add color. You can choose any color of your choice. Let me add blue. I will run this one. Again, I want to label X and Y. X label is equals to maybe X values. Maybe just need to X values. And Y label is equals to, maybe we can just say that 1 maybe plus log X minus X by 2. Maybe just you can just write it in this way. and we can say that y is equals to, right? So we added a plot. It will be in here. Maybe you can add a main title by pressing main, and maybe you can just write your name or ID. Maybe you can just do that and just comma, and maybe you can add just line type. It is okay. This line type, solid line type is okay. So I'm not gonna change anything else, and I'm gonna run it. Here you go. So you can see that I plot the equation and I take a reasonable interval. So in this particular interval from 0 to 1, I can see the pattern of my particular, this line. So this blue line, it represents 1 plus log x minus x by 2 is equals to 0. And as we discussed in our class, if ever you want to check where the roots of this particular equation lie, you will see there where it touch the x is equals to 0, like the x-axis. Where this, sorry, y-axis is equal to 0, right? So let's just add quickly a b line, and I think let's check. So in task one, you don't need to add any line in here. So the task one, part one is finished. So now you can start task two, part two. Sorry, task one, part two. You can start in here, right? So just do it by yourself. So part one is done. So let's go quickly to the part number two. So in part number two, and do it by yourself, the remaining part, task two and part two. So let's try to plot this equation or this equation or any of this equation in here. Let me just try to like use fourth one, that is have a that have like trigonometric function here, trigonometric. So again, let's check. X is equals to sequence. Maybe I can just say that minus 2 pi to 2 pi, and maybe length out length that is equals to 20. Let me just take this interval in here. So I have created a new x in here. So students, if ever it is not mentioned, this is radian or whatever. So let's imagine that your question is in radian. So I'm gonna consider these values in radian as well. So minus pi 2 plus 2 pi, like it will be a complete interval. Okay, so corresponding y values, y will be equals to, I can say that x sine x minus 1, x multiplied by sine x and minus 1. So just to be clear, I'm just going to add the brackets. Sorry. All right. I'm just going to run x, y. So let's check what values of y I get it. Now, students, you can see that the value of y will be within the range minus 1 to minus 1. Then I think it goes to plus 1 somewhere. I don't know, but this is the value. So let's try to plot it. All right. So for the plot, again, I'm just going to copy and paste this one, and let's try to edit it. So in here, I'm just going to copy this one. This is the only different thing that, okay. So now let's try to add an orange color in this one and plot it. So I have my x, my y, and plot. So this is a function, like this is the equation of your particular line. All right, so on here you have x values starting from minus 2 pi to plus 2 pi. And in here you can see that there are intervals when you can have more than one root. For example, if the interval is minus 2 pi to plus 2 pi, there will be more points where it is touching the y is equals to 0. Let's try to draw a plot by using a b line function. I want to draw horizontal is equals to 0, and let's say col is equals to black and run it. So a line is added in here. So you can see at this point or this point. So if my interval is between this and this, let's try to check an interval. You can use this interval, but let's try to check pi and pi. So I have interval. Let's try to check 0 to pi. So I have this one. So it's up to you that what interval do you choose. So again, if you go back -2 pi, you will have this line. So in exam, if I ask you this type of question, so in that case, there will be an interval given that find the real roots of this particular equation by considering this interval, all right? So in task 2, part 4, plot the following function. In this one, the interval should be such that roots will be in given one. So we choose like such that the roots lie in this interval. Okay, use AB line to mark the boundary. So I already marked this boundary. So somehow I can also add the vertical line by just changing the horizontal. I need vertical line. Let's try to draw a vertical line at maybe -4 and +4, -4, a vertical line, and let's just put it green and run it. So this will be my boundary, and let's just say green. This is my boundary. Within, you can say that the roots lie. Okay, also add a point at the root of the given equation. So you can add the point like using points function, and maybe you can just say that, let's say in here my values are 0. Let's say when the value of y is 0, almost 0. But I'm not sure when the value become exactly 0. So maybe let's check that my x value should be, maybe let's say pi and y value should be 0, and PCH is equals to 20. PCH tell you the type of point, and maybe you can say that color is equals to black. So I will just add it in here. So my point is somewhere here. So by zooming, you can just move it a little bit in here so that the point is exactly there. So you can do it in your homework. Not exactly, but you try to create it over exact point. Okay, so you can just zoom like in this way and bring your here and try to look somewhere here, your equation where your point lies. So anyways, so that's the for the part 2. And for the part 3, plot the following equations again with the plot function and the plot of the equation. Okay, so in here we need to equation and its derivative. All right, so let's try to do it very quickly again. So let's say that we have task 3 and let's say part 1. All right. Again, in here, I'm gonna add, these are functions. So let's say my x is -2 pi to +2 pi, and x is equal, my y is equal to sine x uh, plus x and -1. So this is my y. And if ever I take the derivative in here, so it will be 2, and the derivative will be derivative of sine x is equals to cos x, and derivative of x will be equals to 1. Yeah, so this is the equation. Let's say this is equation, and this is the derivative of the equation. So let's try to run this one. All right, so we have x. So let's just check x. We have x perfect. We have y, and we have y too. All right. The next thing is that we will learn how to plot two lines on the same plot. So again, I'm just going to copy this one in here. And here you go. I have new x, new y, and over here, I'm just going to copy this one copy, and it will be in here. So let's just try to plot, run. So I have a plot that look like this one. So students, in R, you can plot another line in the same plot by using lines function. So in lines function, always remember x should be same. This x should be same. And now you will do y2. This is your y2. Again, you can just say that um, maybe color is equals to maybe red. So let's add this line in here. So now you can see that this orange line represents the equation, and this particular red line, it represents your what you can say that the derivative of this orange line. All right. If ever you want to add the maybe legends in here, you can use the command legends. And let's say I want to add it top left corner. I just want to add top left corner, and I can say that my legend should be equals to um let's say my legend is y and y2. These are I'm just writing text. So and then you can give the different color, like I want the first one is for y. For y, I gave the orange color. So let's keep it consistent. Orange, comma, and red. Okay, so let's run this one in here. So you can see it's added in here. So I think we need to add one more thing, line type. Maybe you can just add C1, 1 for the both because it is solid. Now the things will look better. Now I plot it again. So red line is for y, and y2 is the derivative. So in here, because I don't have much space in here, I can just write the whole function in here instead of let me just try to write it. You will see that instead of y, I will just write the whole function and try to plot again. All right, so it looked a little better. So I can just copy it again in here, and instead of y2, I will just write it in here. So just plot again. All right, so in this case, you can just remove your y label to just fx, just all right. So I think that's it. Choose and work carefully, and so you can just add at the end, great, and I think that's it. So all of these three from class 1, 2, and 3, I solved one problem. So I believe that you guys will do it at home and try to upload the homework number 3 very quickly. So students, there is another easier way to plot a graph by using the curve function. How we will use the curve function? Maybe in a separate video, I'm gonna tell you how you will use the curve function